Hello everyone. Here we have a special treat. We have the Model S plaid battery, open, exposed. Here in this video I'm going to go over the whole battery, all the systems in it, and talk about how it differs from their other offerings. So this battery's obviously already been opened. This is the front of the car. Gone are the quick connects. This is no longer a quick connect capable battery. It's bolted into the car. Requires a lot of fasteners to be removed. It's not going to be quick swapped. There are removable connectors just to aid in production. On top of this area here, which is the penthouse, we have the same exact PCS. It's being used in Model 3 and Y. This is an evolution. There's been some subtle changes, some cost downs, and other things, but basically the same 48 amp, 11 kilowatt charger and DC-DC converter. I've outlined this in another video. It's 3 identical phases here. AC comes in here, DC goes out to the pack here, high voltage DC, and this is the DC-DC converter, which does the function of the alternator in an electric vehicle, also runs in reverse during pre-charge to allow the high voltage system to come up to voltage before the contactors close. Under the PCS, we have all the high voltage equipment here. This black box is lifted from Model 3 and Y. It is the battery management system and high voltage protection. It's the exact same module. The plastic is even, like this is a relief for the brackets that connect to the seat brackets under the penthouse of the Model 3 and Y. They just threw it right in here, no changes. Same hardware, just slightly different software. Here we have 2 fuses. These are for the PCS high voltage feed and the air conditioning compressor or heat pump compressor. This connector here is for the front motor. This is the 12 volt positive high current connection, which goes up to VC front. This is the data connection with the CAN bus. Here we have the high voltage pyro fuse. It's a newer, bigger design, but basically the same basic concept. I have another video I'll do on this by itself. This one's been blown. This pack was an accident. As soon as the airbag system deploys, it opens the pyro fuse. This is the negative most contactor. So right here we have the busing that comes off the end of the module number 1. So this is the most negative side of the pack. Comes out of here, goes through the fuse, through the negative contactor, and into this bus bar here, which comes down, serves the front motor and the 2 high voltage ancillaries I just talked about, as well as going through this giant bus bar, which goes all the way to the back of the pack for the rear motors. Here's the glycol coolant inlet and outlet. As you can see here, this is where Brondo goes in and Brondo comes out. It's got what packs crave. The manifolds are, this is machined out of there's plastic manifold, but these inlets are machined out of billet, looks like. They go into what looks to be an aluminum extrusion that runs very similar to the existing pack design in between the 2 rows of 18650s here. Yes, these are 18650s. It's really easy to see the diameter of them. I've done calculations, and this is 22 serial rows of 72 cells wide. So there are 5 of these modules. That's a total of 7920 cells for the whole pack. 110 total cells in series. The coolant manifold runs down the entire length of the passenger side. There's nothing coolant related on the other side. We have the elastomeric poppet vents for venting gas pressure if it were to ever develop in the pack, but not allowing water into the pack. We also have the same or very similar design as to what was found in Model 3 and Y for venting liquid from the pack envelope should it ever get wet. Can't get that one out, but we'll pull one out back here. I've already removed. So this is an interesting device. This is the inside. There's a O-ring here, and this is held closed with a ring in here that's made out of cellulose that dissolves when it's in contact with water, liquid, Brondo, urine, whatever. The powerful spring that's in here will pop this open and allow that liquid that's inside the pack envelope to drain out. The only difference is on Model 3 and Y, these are supervised with a switch. They have a magnet on them and then a Hall effect sensor so that the BMS is aware if that happens. Here, they didn't bother doing that. I imagine they're just depending on the isolation detection to let you know that the pack has Brondo in it. So while we're back here, we can see the rear of the pack. These are the two connectors for the rear motor. What's happening here is this is the very positive most bus bar of the pack. It comes out here through the positive contactor to the motors on each side, and then also returns back down in this bus bar to the front of the pack to power the front motor and the high voltage ancillaries. Also, the positive connection goes through this contactor and then to the connector that goes to the charge port. Same thing, negative comes back, another contactor to the negative bus bar, so that when you're doing supercharging, you're directly connected through these contactors to the pack. Let's see, what else? The interior design of the pack, there's a row of 18650s and a single file row here that runs all the way down, 72 cells, and then you have the cooling manifold, and then an offset, since the cooling manifold looks like a little wavy zigzag, so the cells fit into that cooling manifold. So these cells are offset a half a cell in diameter, and then we have another row of cells, another cooling manifold, another row of cells, and so on until all 22 are done across here. One interesting thing that's changed is the interconnect. Underneath here, you can see we have tin metal that's been spot welded. So the end of the module has tabs that come out. They're folded over, that's this, and then spot welded to this interconnect. And these look like fuses, but the main intention here, I believe, is for mechanical relief. So these can move and vibrate and not tear the spot welds off. You could remove these spot welds and separate the modules and then re-spot weld them if you needed to service them or repackage them if you were doing conversion. Obviously, you'd have to also handle these manifolds, but as you can see, they have quick connects at the cell boundaries, or the module boundaries, so it would be easy to service. And now on the business end, or the electrical business end, we'll start at the front of the car. So the circuit board runs the entire length of the module. Inside here, we have the current collectors that join the top of the cells. They come out and are folded over and attached to the circuit board here. So these function as the cell taps so that the BMS ICs here can sense and balance. And this is the same arrangement as used in the 3Y. There's an isolated bus here that's twisted pair, single twisted pair, comes out of the BMS computer in here, goes through chip 1, through another galvanic isolation transformer, chip 2, transformer, and so on. It goes all the way down like that in a daisy chain. And if the chain is broken anywhere, the BMS can read the state from the other end. So it's got some redundancy. Again, this is the same architecture, just repackaged a bit from the Model 3 and Y. Again, same current collectors here. We have interlock on the high voltage connection to the charge port. That's what that connector is. This connector, which is orange, is the high voltage coming from where the charge port connects there and travels back down as the AC input to the PCS. And of course there's the black cable, which is the data traveling from the front to the rear. Trying to think, oh yeah, so I don't think I covered the high voltage flow here. Yeah, I guess I did. So this is the current sense for the pack. It's a current shunt. It's calibrated shunt. It looks the same as 3Y and S. Very most negative terminal of the pack, through the current shunt, through the fuse, through the contactor, and off. So one interesting difference is this pack is fused at the negative end. It's not broken in the middle or somewhere else. All the modules are welded together in the middle. So you have full pack voltage from end to end, which is, roughly 450 volts. This pack is for sale. It's a fully functional pack. It's got about 35% state of charge right now. No isolation faults. The only thing wrong with it is the blown fuse and the removed top cover. There might be a few bits of plastic here and there broken, but other than that, it's fully functional and for sale. If you want to investigate purchasing this, you can contact me by going to the About Me page on my channel page, where you'll find an email address. You have to be signed in to YouTube to get access to the email address. Drop me an email, and I'll put you in contact with the owner. If you have any questions, you can also email me or leave a comment below. I try to read and answer all the comments. I'm going to be doing some more teardowns from the plaid systems. I'll also post all the technical measurements and a description of the module configurations in the description of this video. If you don't see what you're looking for, drop me a comment. That's all I have. Have a good day.